Hello and welcome to Mr. Thompson's Math Tutorials. Today we're going to be looking at something that's just called the product. But really all this is the distributive property in a slightly more complex form. So let's just quickly review the distributive property. I often use the distributive property when I'm multiplying something like, I don't know, 6 times 27. And the way that I do this is I think to myself, well, actually 6 times 27 would be the exact same thing as 6 times 20 plus 7. Okay? Um, so 20 plus 7 is 27. So multiplying 6 times 20 plus 7 is the same as multiplying 6 times 27. Now the distributive property would state that I could multiply this 6 times this 20 and this 6 times this 7 and then add together those products and I would end up with the product of 6 times 27. So let's just see. Let's see, 6 times 20 plus 6 times 7. So 6 times 20 would be, let's see, 120 plus 6 times 7, which is 42. So this would be 162. Let's just check that the old-fashioned way. So if I do 27 times 6, let's see, 6 times 27 is 2, carry the 4. 6 times 2 is 12 plus 4 would be 16. Okay, there we go, 162. Now, it works. One sort of central idea in math that if it works for something like this, then it also must work for something like this. This is not that different from what we just saw. This is really 2 times and then x plus 4. You can't really tell, but there's actually a multiplication sign. It's hidden, but there's a multiplication sign right here between this 2 and the bracket. So the distributive property would state that I can multiply this 2 times this x and this 2 times this negative 4, and that would be the same as the distributive property that I just showed you using the 27 times 6. So let's see, 2 times x, that's 2 groups of x, which would be 2x. And then I have 2 groups of negative 4. Well, that would be negative 8. Okay? This is another example of the distributive property here. Once again, you don't see it, but there's actually a hidden ghostly multiplication sign between this 3 and this bracket right here. Okay? But I'm going to, again, multiply this 3 times this x squared, this 3 times this 4, and this 3 times this negative y. Okay, well, I have 3 groups of x squared, so that's going to be 3 groups of x squared, which is x squared. I have 3 groups of 4, which we call 12, and I have 3 groups of negative y, so this would be 3y. Again, this is the distributive property. This is something that we're pretty used to dealing with. Now, what happens when I have this? Now, this is not that different than what we have just looked at. Okay, again, there's a little multiplication sign between these brackets, but now I'm multiplying this whole thing times that and times that. So let me do these in different colors, but essentially what I'm doing is I'm multiplying this way. I'm going to be multiplying I'm going to do this in red. Okay, so I'm multiplying my x plus 1 times, oops, I'll use a dot for my times just because I don't want to confuse you. Okay. Sorry, my keyboard came up there. Okay, so I'm multiplying this x plus 1 times this x. Okay? And I'll put this in brackets. I'm also multiplying that same x plus 1 times this 1. And again, I'm going to put my x plus 1 in red. Okay, so there we go. And sorry, just to keep consistent, I'll keep this bracket in black. All right, so I need to multiply this x times this x and this x times this 1. It doesn't really matter that this x is after this x plus 1. Okay, it doesn't matter. Okay, and I'm also going to do the same thing here. This 1 gets multiplied times that x, and also this 1 gets multiplied times this 1. Okay, so let's start here. This x times x. So really, I've kind of set myself up with 4 different multiplication problems. This is a positive x times a positive x, which is going to give me x squared. Okay, plus I've got a positive x times a positive 1, so that's just going to give me an x. Plus, this is this plus down here. Okay, I've got a 1 times an x, so this is a positive 1 and a positive x, so that's going to give me x. I've got a 1 times a 1. 1 times 1 is a positive 1 times a positive 1. That's going to give me a positive 1. And then what I want to do is I want to kind of collapse this thing back together and add together like terms. Like terms have the same exponent and the same variable. So as I look at this, I've got this term right here, and this term has an x as a variable. There's 2 other x's here, and a 2 as an exponent, but neither of these 2 have a 2 as an exponent, so they're not like variables with this term. However, this has an x as a variable. This one has an x as a variable. This also has an x as a variable, and their exponents, although you can't see them, they're actually there. They're an exponent 1, and again, I like to call them ghosts, but there's a ghostly 1 there. Okay, so I can add those 2 together. So I would end up with x squared plus 2x plus 1. And that has been distributed. Okay, here we go. Let's look at another example of this. Once again, what I'm going to be doing is I'm going to be multiplying this whole term that I'm going to circle in green. This whole thing is going to multiply times this x, and this whole thing is going to multiply times this 2. So one of the things I like to do is I like to write this x minus 2, whatever that term is. I'm going to do it in blue. So x minus 2. And then I'm going to use green for this. I'm going to multiply times this term, this x minus, or x 2x minus 4. So that whole term is getting multiplied times this blue x. And then I'm going to do the same thing over here. I need to multiply this negative 2 times this 2x minus 4. Now that negative 2 is going to become very important in a minute. But let's distribute this x first. So this x is going to multiply times this 2x, and this x is going to multiply times this negative 4. So x times 2x would be 2 times x times x. Okay, the negative 4 is also being multiplied times this x, this blue x. Okay, I'm sort of leaving this in an expanded form for a second. I'm going to move on to this that I'm going to multiply or show in red here, or underline in red. So now I'm multiplying a negative 2 times, this is a negative 2. This negative 2 is getting multiplied times this 2x, and this negative 2 is getting multiplied times this negative 4. It's really important to understand that that negative is going with the 2. So negative 2 times 2x. So this is going to be a negative group of 2x's. So 2 negative groups of 2x is what that stands for. So this is going to be negative 4x. And then I have a negative group, 2 negative groups of negative 4, which actually gives me a positive. So that's going to give me positive 8. Then I'm going to collapse like terms together. Now, this becomes 2x squared. This is going to be 4x minus 4x plus 8. Okay, this does not have the same exponent. This term does not have the same exponent as these 2 terms, so I can't add those together. But I can add these 2 together. Now, it's really important that you understand that this negative goes with this negative right here. This negative goes with this negative 4x, and same thing here. So this is negative 4x minus 4x. So I've got that. Negative 4x minus 4x would be negative 8. Negative 8, come on, my pen's being a little tricky. Negative 8x Sorry about that. Like I say, my pen's being a little tricky. Okay, let me just rewrite this. 2x squared minus 8x plus 8. Ignore this. Sorry about that. Okay, and that has been distributed. Oftentimes people, another way to think about this, and in fact, I'll just show this real quick. Let me just clear the ink on this. So cleared the ink. Okay, so another way to think about this, and you'll often hear people talk about this, they'll talk about it as FOIL. And it's up to you if you want to think of it this way. In FOIL, what you're thinking of is this. The F stands for first. The O stands for outside. The I stands for inside. And the L stands for last. And this is kind of another way to do this. So if you choose to do this way, what you would do is you would multiply the firsts. So you'd start by multiplying the firsts. So that would be my 2x times x. Okay? So those are my firsts. That's this times that. Okay? And then I'm going to add my outsides. Okay? So outsides would be this and this. Okay, so I'm going to change that to a different color. That would be my 2x times negative 2. Okay, that's outsides, right? Because they're both on the outside of the brackets. Okay, then I'm going to do the insides. So this is going to be in a different color, but these are the insides right here. These two are insides. So I'm going to be multiplying those together. So it would be negative 4 times x. Okay, and then lastly, I'm going to be multiplying the lasts. So that would be this and this. So that would be negative 4 times negative 2. And then I would just simplify this. So starting here with the black couple of terms, this would be 2x times x, which is 2x squared. And then I'm going to be adding. Actually, I'm going to be subtracting because this has a negative right here. I've got 2x times negative 2, so that's going to give me negative 4x. I've got negative 4 times x, which is negative 4x. And then I've got negative 4 times 2, which is positive 8. Okay, and again, I'm just going to collapse this together. So this would give me 2x. This is going to give me negative 8x. And then plus 8. And this is the same answer that we saw earlier. So I'm happy for you to use either method. The FOIL also works. Okay, thank you for watching.